Hello and welcome to this video tutorial. Today we're going to introduce the first law of thermodynamics. Let's begin. Please remember to pause or rewind the video as necessary. Gas gives me work. During a Monarchs game, Ticha passes the ball to Yolanda. Yolanda catches the ball. What kind of work did each woman do on the ball? Defend your answers with a sketch that includes the appropriate vectors. Well, recall that work is equal to a change in energy, right, of an object. Meaning, if the energy increases, right, then positive work was done. If energy decreases, right, then negative work is done. So with Ticha passing the ball, what is she doing? She's increasing the kinetic energy of the ball. Therefore, she does positive work on the ball. Another way you could look at it is work is equal to the product of the force and the displacement vectors. It's the force applied times the displacement that the object moved. So if she pushes the ball forward and the ball goes forward, right, you can see positive work, right, was done. Whereas Yolanda, she catches the ball. So by catching the ball, she's slowing down the ball, reducing the ball's kinetic energy. In other words, she does negative work on the ball. Another way to look at that is the ball is moving forward towards Yolanda, but she applies a force backward on the ball and thereby does negative work. Now, to apply that to a gas, part two, consider a gas enclosed in a container with a piston that can slide. How could we increase the energy of the gas molecules? Well, if you recall from our bouncing off the walls PhET lab that we did, when we make the volume smaller, the kinetic energy and thus the temperature of the gas goes up. So we can push the piston to the right, and decrease the volume. Okay, so by doing this, we have done positive work on the gas. Now, decreasing energy, well, that would be pulling the piston, right, and increase the volume. Right? Such a process would have done negative work on the gas because we've decreased the energy of the system. So under what circumstances would no work be done? Well, no work is done when there is no change in volume. So in other words, we have to have some kind of volume change in order for work to be done. Now what we're going to do is we're going to construct the actual first law of thermodynamics. So consider a situation where we have a gas enclosed in a container with a fixed volume, okay? And the flame, right, is adding energy to the gas. Well, what kind of energy is the flame adding? It's adding thermal energy or heat. The variable, the symbol for that is the upper letter Q. Temperature is a measure of the average kinetic energy, right, of random molecules in motion. So what is the name and symbol for the quantity that represents the total energy of the particles? Well, that would be what is called the internal energy. So the internal energy, which is the letter U, measures the total potential and the total kinetic energy of molecules, right? But here's the catch. Ideal gases, like which ones are used in this model, they don't attract each other gravitationally. And since they don't attract each other gravitationally, they have no gravitational potential energy. Therefore, the internal energy of the gas is pretty much related to the kinetic energy of the gas, which, by the way, is measured by the temperature. So you can see how the three concepts will end up relating to each other. By the way, something to note, if U is the internal energy, delta U would be the change in internal energy. So how does the increase in internal energy compare to the heat added? Well, if we add more heat, the kinetic energy goes up. If the kinetic energy goes up, the internal energy goes up. So the change in internal energy is completely related to the heat that is added. So suppose we take a can and we replace the can with frictionless walls and a piston, and a weight is placed on the piston and the piston descends. Now the temperature of the gas increases. Now if that's true, then the internal energy, right, is also going to increase, right? So the internal energy is going to increase as the temperature increases. What's the source of this change? Well, that would be the work done on the gas. How does the increase in internal energy compare to the work done on the gas? Well, the change in internal energy is going to be equal to the work done on the gas. And if we have a gas that's heated and a weight that's been placed on it, that means the internal energy change is going to be equal to the heat added and the work done on the gas. Now, this is for a compressed gas situation. The opposite is true for an expanding gas situation. And that would be delta U equals Q minus any work done by the gas. This is known as your first law of thermodynamics. Now, typically, I'm going to be using the first one, but the second one is easy to come by.